Okay, so let's talk about one last way to describe the equation of a line in three space. And this last way is called with a symmetric equation. Okay, so essentially what we're doing for the symmetric equations is we are eliminating the parameter t from the equations in 2. And do we remember the equations in 2? They are as follows: x equals x naught plus ta, y equals y naught plus tb, z equals z naught plus tc. And remember, t is any real number, and another way to write that is to say that t is in between infinity and negative infinity. Okay, so now what does it mean to eliminate the parameter? Well, let's see here. So if we know that x is equal to x naught plus ta, that means that x minus x naught has to be equal to ta, right? And y minus y naught has to be equal to t times b. So if a isn't equal to 0, then, and b isn't equal to 0, we could just divide both sides to get t by itself, right? And so then we end up with x minus x naught over a equals y minus y naught over b. Does that make sense? And we can do the same thing, because if we have z minus z naught is, right, so I'm just subtracting z naught from both sides. So I get z minus z naught equals tc. So if c isn't equal to 0, then that means that t is equal to z minus z naught over c. Okay, and these equations, right, this equal to this equal to this, are called symmetric equations of the line. And this again is assuming that a is not equal to 0, b is not equal to 0, and c is not equal to 0. Okay. And we have different versions if, for instance, if a is equal to 0, then, so let's see here. So imagine if a is equal to 0, then remember how we have x equals x naught plus at? If a is equal to 0, then that means that that goes to 0. So we just have x equals x naught, but we can still solve these other two, right? These other two expressions, right? We can still solve for t and equate these. So if a is equal to 0, or b is equal to 0, or c is equal to 0, then we end up with, right? So this is one equation, that x is equal to x naught. And we've got this other equation. So here's equation number 2 and equation number 1. And this is a really important note right here. This means that the line lies in the vertical plane x equals x naught. So what does the plane x equals x naught look like? So say if here's x naught, the plane x equals x naught is vertical, okay? And our line has to be in this plane because every point x, y, z that's in the line has to have that x equal to x naught. So that means that our line has to be, it can't stick out like that, because this would mean that you've got some x values that are not equal to x naught, right? So let me highlight this. If a is equal to 0, then these are our symmetric equations. And since we have x equal to x naught, that means that our line lies in the vertical plane x equals x naught. Okay. All right. Let's do a quick example. So we're going to find parametric equations and symmetric equations of the line that passes through these 2 points. And so just to give us an idea, we've got, so we've got 2, 4, negative 3. So I'm just going to come up 2, and 1, 2, 3, 4. So 2, 4, and then 1, 2, 3. Down 3. Okay, and then 3, negative 1, up 1. Okay, so here's A, and we've got our point B. Now remember, what do we need for the equation of a line? We need a point, and we need direction. So to get our direction, we're going to look at, we can look at the vector, right? We can look at this displacement vector, okay? So we can have our point, or our position vector, we can call it that. Position vector can be 2, 4, negative 3. This can be our R naught. And the direction vector can be the vector, let's see here, so it can be the vector from A to B, from A to B. And how do I get that vector from A to B? Well, I'm just going to subtract. So I'll have 3, negative 1, 1, minus 2, 4, negative 3. Okay, so then I just end up with 3 minus 2 is going to be 1. Negative 1 minus 4 is going to be negative 5. 1 minus negative 3 is going to be 1 minus negative 3 should be 4. Okay, so now that I have I've got my position and I've got my direction, so I know my equation, my vector equation. Let's add a page below. So my vector equation is going to be R equals R naught plus TV. Okay, and so that'll be R equals R naught, which is 2, 4, negative 3, plus T times V, which is 1, negative 5, 4. Okay, which I can write that as 2 plus T I, okay, plus 4 minus 5T J, okay, minus 3 plus 4T, or minus 3 minus 4T. Okay, that's the vector equation. And then this is just practice, right? Parametric equations. Let's write our parametric equation. So for our parametric equations, it's really easy to do that once we've written our vector equation in component form. So we'll just have x equals 2 plus t, y equals 4 minus 5t, and z equals, we can put negative 3 plus 4t. Okay. And then lastly, we want the symmetric equations. And the symmetric equations, let's see here, how are we supposed to do that? Remember, we're supposed to solve for t. So if I solve for t, then I get, so I want to say x minus 2 equals t. Okay, and then y minus 4 equals negative 5t. So I'm going to divide by negative 5. And I get t equals y minus 4 over negative 5. But t is also equal to x minus 2. So that's my first, is going to be x minus 2 equals y minus 4 over negative 5. Okay. And then the last I need is z plus 3 equals 4t. So now divide by 4. And I have t equals z plus 3 over 4. I'm going to add that, z plus 3 over 4. Okay. So we've got this, got here, and we've got Okay. And what's the last thing we needed to do? At what point does this line intersect the XY plane? Okay. So what does it mean to intersect the XY plane? Well, the XY plane is the same as this horizontal plane here, right? So the XY plane, the equation of the XY plane is z equals 0. So in order for this point, so in order to have a point XYZ is on the line, and if XYZ is in the XY plane, that means that we know that Z better be equal to 0. But once we know that Z better be equal to 0, we can use our parametric equations to say that if Z equals 0, then 0 is equal to negative 3 plus 4t. So we can figure out at what time our line passes through the XY plane. Okay, so it must be 3 equals 4t. So t equals 3/4. Okay, so now I know when t equals 3/4, the magic happens, i.e. our line is intersecting the XY plane. So now let me put that back in and determine x and determine y. So x is supposed to be 2 plus t. Okay, but now t is 3/4. So that'll be 2 and 3/4. 8, 9, 10, 11 over 4. And then if we have y, it's supposed to be equal to 4 minus 5t. So that'll be 4 minus 5 times 3 over 4. So that'll be 23. That'll be 16. So that is...
it's 22 hours.
Thank you. So negative 7 over 4. So 11 over 4, negative 7 over 4, and then lastly, z is going to be 0. So x, we said, is equal to 11 over 4, and y is equal to negative 7 over 4. So what's the point? The point is going to be 11 over 4, negative 7 over 4, comma 0. Okay. If I did my math correctly. Let me just verify that. Thank you. Let me verify that. Okay, so 4 minus 5 times, so that is what am I thinking? I see the error that I made. The error is here. So this 5 times 3/4 should be 15 over 4. Okay, and so now we'll have 16 minus 15. So we should have 1/4. Okay. So we'll have 1/4. And, do I have to fix it over there? Yeah, okay. All right. So, here's just something to note. Direction number is something that is that's not a common terminology, but it is something that our textbook uses. And it's just a way to describe the numbers that are in your symmetric equation, the denominators in your symmetric equation, because those numbers correspond to give you a ratio for the direction that your line is traveling, and what your line is traveling. Okay, so we did that. Well, here's what I wanted to get to. I wanted to get to this picture here. This is the picture of our line, and that point P is where where the line is intersecting the XY plane. Okay. All right. And the last thing I actually want to say here is that sometimes you don't need the entire line. You just need a line segment. Okay, and if you need a line segment, then what do? Well, you restrict the domain of t. So remember, t is your parameter. And if you want the whole line, then you let t be in between negative infinity and infinity. If you just want a line segment, then you could restrict. So you could say, oh, I just want t to be in between 0 and 1. Or I just want t to be in between negative pi and pi, right? And by restricting t, the results will be a line segment, just part of the line. If you wanted array, so imagine if you wanted just array, well then you might choose t to be greater than or equal to 0, right? Or some number. Does that make sense? Okay. So, yeah, oh, that's really good. And again, I'm not going over every single topic that's in the section, but I do want to just highlight some points. Okay, so I'm assuming that you're going through reading, taking notes on the textbook reading, and you're also watching these videos, which are mimicking or modeling the highlights of the textbook.